Math 95. I'm your instructor, Adam Kepke. Today we're going to be covering the first two sections, which is the properties of arithmetic and their applications, as well as the order of operations. There are PDFs available for you online in the Unit 1 module. They're pretty much going to cover the same material. I may do some different examples in there just to give you an opportunity to practice some other ones at home on your own. Of course, if you ever have any questions, always reach out to me. I'll make sure that we have a few meetings a week just so that we can talk about things that we're going over, just so that it's not all as disconnected as this. So let me switch this over real quick. This is the whiteboard that I'll be using for all of our lectures. In this lecture, like I said, I'm going to cover the properties of arithmetic. One more thing. Flip this back over. Get a calculator. This is one I like using. I gave you the link to Amazon for it. You can also get it at Target or Walmart or wherever. It's the TI-30XIIS. I prefer this one. Of course, if you have another calculator that you have been using all along and you want to use that, you certainly can for this class. I will say for Math 120, they're going to want you to have a non-graphing calculator. So if you don't have one of these, if you're using like, I don't know, a TI-82 from your SAT or ACT or whatever, I don't really mind, but get comfortable with a calculator that's not necessarily your graphing one between now and then, because they're going to ask you to use that in 120. So this is the calculator I'm going to be using for the whole semester. And like I said, if you have questions about the way that your calculator that you're using right now is operating, send me a video or send me an email with some screenshots, and I'll hopefully be able to navigate through it with you. Okay? All right, now back to our lecture. So I'll leave this guy over here somewhere in case we need him once in a while, okay? The properties of arithmetic is actually a really easy lecture to go over. Traditionally, it's something that we did without a calculator, so we would talk in great detail about properties of adding and subtracting integers, multiplying and dividing, these rules. Really, it's more of a get used to your calculator thing at this point, right? If you're not sure about a particular arithmetic question, don't wing it. You have this tool with you, use it at all times. I built the course with the idea that in the real world, if you don't know, an extremely long division problem, you're not going to sit down on a piece of paper and do it. You're going to go to the first piece of technology you can find, your phone or a calculator laying around, or the internet, and you're going to do the math. It's going to do the math for you. The most important thing about this class and what you're doing is knowing what math to do. Am I supposed to divide here? Am I supposed to multiply these values? And what rules am I supposed to apply? That's going to be the most important obstacle that we're going to overcome in the first few lectures. Okay. So, welcome to Lecture 1, Arithmetic Properties. So for arithmetic properties, the main things that I want to talk about are the rules of addition and subtraction and the rules of multiplying and dividing. So I'm actually going to start with adding and subtracting integers. By the way, an integer is a whole number, positive or negative. Zero is also included in this list as well. All right, bear with me. I have a broken foot, and so moving around, even on video, is never easy. So in the rules of adding and subtracting integers, what I want to refer to them both as is combining integers. So this is what we're going to call combining integers. In this idea, what we want to talk about is that we're not really adding or subtracting when we have these values. Really what we're doing is we're assigning a positive or negative sign to every number and then figuring out, are these numbers working together or are these numbers working against each other? And I'm going to give you an example here in just a second. So the example that I want to do is, suppose I had something like -5 plus 8, for example, and I wanted to combine these values together. our rules for combining integers I'm going to put over here on the side. Our first rule is always trust the sign to the left of a number. In this particular problem, our 5 is negative and our 8 is positive because we're trusting the sign to the left here. And of course, we know if a number's out in front and it has no sign, then we just assume that that value is positive. And then here are our two rules. Values that have the same sign, we're going to add and keep that sign. Whereas values that have opposite signs, we will subtract and keep the sign of the larger number. So we go back to this problem that I have here, negative 5 plus 8, and like I said, we identify the 5 to be negative, and we define the 8 to be a positive. And so these values are working against each other. They have opposite signs. They fit this bottom category here, and so we should be subtracting these values. The order in which you subtract them does not necessarily matter in this problem, because later on we're going to assign a sign to it that's going to tell us whether it's positive or negative. So just really thinking about if I have 8 and I take away 5, I have left over 3. Now the question I have here is my answer positive 3 or is it negative 3? And again, we keep the sign of the larger number. In other words, these two are working against each other. And there was more positive value here than there was negative. And so our final answer here is going to be positive 3. Here are a couple more, very similar. Negative 5 minus 8. I'll put 5 minus 8 here. And we'll do 5 plus 8. In each one of these, we're going to identify whether we have the same sign or opposite sign. In this case here as well, I'm going to say here we have the same sign. Our 5 is going to be a minus or a negative. And even though it's like a subtraction here, what I'm doing is I'm taking this 8 and I'm taking this negative and I'm assigning it to 8. And so in this problem here, what I'm looking at is I'm combining two negative numbers. When I combine two that have the same sign, I add them. 5 plus 8 would give me 13. And then I keep the sign that they share. In this case, I was negative 5 and I went even more negative, 8 more spaces, so now I'm all the way out at negative 13. 5 minus 8, very similar to the previous one that we did before. There's no sign here, we assume it's a plus, and so these two values here have opposite signs and we subtract. When I subtract 8, take away 5, I get 3, but in this problem, notice that the 8, which is the larger number, is negative. And so our final answer here is actually going to be negative 3. And then lastly on the bottom we have 5 plus 8. We're adding these values together. They have that same sign. We add them together and it's 13. Because they both have a positive, our final answer is positive as well. On our good friend the calculator, there is a difference between the minus and the negative sign, so just be careful with that. Really, in the way that I treat combining integers is that the minus and the negative are interchangeable. They mean the same thing. But in this calculator, if you need to use a negative, it is this value right here next to the decimal. So this is like a negative in the front, negative 5 plus 8, for example. But then not to be confused with the subtraction if I want to do like negative 5 minus 8, right? So in between two values, you want to use the minus sign. In the front, if you want to, you can use the negative. Okay. So the other thing we want to talk about is multiplying and dividing integers as well. The rules of multiplication and division, there's not too much to it except for the sign rules. It's probably the first thing we should start with. And I always think of married couples when I think of the sign rules. If you have two values that are the same, then they're going to get along just fine. Two positive people are going to probably have a nice positive relationship, or similarly, two people that are both negative probably have some reason to complain together. They get along too. But when you deal with one that's positive and one that's negative, this is where that shift happens and things are not going to go so well. And so the negative always ends up dominating when you're multiplying values together. This is also true for multiple signs in a problem. So if you have something like -5 plus a -8, for example, something like this, these two signs right here can be consolidated into a single sign just by following our rules for multiplication and division. So going back to the one that we were just doing with the 5s and the 8s, if I had a problem that had this combination of plus and minus in there, I can consolidate that into a single sign. A positive and a negative, a positive and a negative make a negative. And so really I could rewrite this as this. These mean the same thing. Now for multiplication, of course, we can also use our good friend the calculator. Our times symbol here is the one that we want. So something like -5 times 8 if we want to do something. Oops, sorry. -5 times 8 if we want to do something like that. We can see that a positive and a negative are going to end up giving us some negative value at the end. Okay, so just keep that in mind for multiplication. Remember that multiplication is a process of repeat addition, right? That if I have something like, I don't know, let's say 5 times 8, for example, but that means the same thing as taking 5 and adding it together 8 times. Or taking 8 and adding it to itself 5 times. We'll talk more about this in the next lecture when we talk about order of operations and why we do multiplication before we do addition. Because really what it is it's a series of a bunch of these calculations at once. Other rules for multiplying and dividing that we need to talk about are the rules for 0. For multiplication, anything times 0 is 0. And for division, we have these two important rules that I like to use, which is how do we divide with 0? So before we talk about that, actually, let me just give you an example for division. Division is kind of like splitting something up equally amongst a bunch of groups. So if I had something like, I don't know, 21 divided by 7, right? Maybe that's saying I have 21 pieces of candy and I have 7 people here that need to share this candy. How many pieces of candy does everybody get, right? So I could take this 21 and I could break it up into 7 equal spaces. And then I could just start distributing this candy along the line. Here's 7. Now everybody gets 2, and now I'm at 14. Everybody gets 3, and it turns out I'm exactly at 21 now. So everybody's going to get 3 pieces of candy in this division. So how does that work then if I want to divide with 0? Well, let's think about it. Suppose I had something like 0 divided by 7. Well, that's saying something like I have 0 pieces of candy and I want to split them among 7 people. So how many pieces of candy is everybody going to get? Well, sadly, I have no candy to share, so everybody gets 0. However, if I ask some question like 7 divided by 0, well, this becomes a much more abstract idea. This is saying I have 7 pieces of candy and I want to share them among 0 people? Well, how do I share among 0? It's really not something that I can do. It turns out that when we divide by 0 all the time, that we get a value that is not defined. We just say that this is undefined. And if you have deeper questions about why it's undefined or what it means to be undefined, certainly let me know. I'll share whatever I know with you. I noticed a student a long time ago showed me this idea that if the number is on the bottom and the 0 is on the top, that it is okay, like this situation that I have here. But if I have some number on the top and I have 0 on the bottom, well, that's no good. So that's another cool way of kind of remembering when I can divide by 0 and when I can't. Your good friend the calculator will also help with this, right? Of course, you could do 0 divided by 7 in here, and you're going to certainly see that it's 7. Notice that the divide symbol in here is also the fraction bar that I'm using as well, not to be confused with the actual fraction symbol in here in this calculator, which we're going to talk about later this week. But 0 divided by 7, 0. When I flip it around, though, and I do 7 divided by 0, the calculator explodes. No, I'm just kidding. It doesn't explode, sadly. It just tells me that that can't be done. That's an error. So if you run into this issue while you're working on an exam or something, a quiz, for example, maybe, you would just tell me that it's undefined. The last concept we want to talk about in 1.1 is the idea of cash flow. What is cash flow? Oh, I've been doing this much. What is cash flow? Cash flow is a way of calculating the amount of money left over after an extended period of time. It can more specifically be thought of as the amount of income that you have coming in minus the expenses that you have to pay for. It's like balancing a budget. The important thing that you need to keep in mind is that each amount must be expressed in the same unit of time. Each amount given in the same unit of time. And so when we calculate our normal budget or our normal income and out expenses and money that we're spending, they don't all necessarily fall into the same period of time. For example, I do my grocery shopping every week, but I get paid every month, right? I get my phone is due every month, but my tuition is due every 6 months. So it creates some sort of an issue when you have a bunch of these values that don't necessarily line up with one another. And so that'll be the first thing that we do. We're going to write out all of these incomes and expenses, and we're going to put them all on a level playing field. And then once we do, we can total them up. We can get a total for the income, we can get a total for the expenses, and then we subtract income minus expenses. Of course, cash flow can be positive or negative. Obviously, if we have a positive cash flow, we're in good shape. We have more income coming in than expenses. And if we have a negative cash flow, then we're spending more money than we're making, which is not necessarily a good thing. So let's do an example. While I'm writing this out, I'll just tell you that I'm listening to Hakuna Matata in the background right now because I have a 2-year-old daughter who's downstairs checking out Lion King. So we got job, let's say, is $700 a month. We got a college fund. Somebody saved some money for you, and they said, "Hey, here's your college fund." We got a scholarship because you're smart. And let's say your scholarship is $6,000 a year. And then we got some expenses here. We got rent. We got groceries. Obviously, your cash flow is probably going to look a little different than this generic example that I'm coming up with. But at some point, I'm going to want you to give me your actual cash flow in a project. Rent, let's say, is $500 a month. Let's say your groceries are $40 a week. Wow, nice. Your tuition is $2,400 a year. Sorry, $2,400 twice a year. And then our incidentals will say just other expenses that you have. We'll call it $120 a week. For this problem, I want to find the monthly cash flow. Always important that you're looking at what I'm giving you in terms of the time. I could ask you for your monthly cash flow, your weekly cash flow, your annual cash flow. Most of the time, though, I'll tell you that the one that's most important is monthly. And I'll make one more piece here. Let's say 4 weeks is equal to 1 month, which is not necessarily the case always, unless we're in the month of February, not on a leap year. So, but for easy conversion, we're going to say 4 weeks is 1 month. So what we do is we look at all these values here. For the ones that are already given to us in month, we don't have to do anything. We can just say, okay, you're 700, college fund is 400, scholarship is 6,000 a year. Well, we know that there's 12 months in a year, and so we need to chop this number up by dividing by 12. When we divide by 12, we get 500. So I put all these in blue so that we can add them up. And so our total income is going to be 700 plus 400 plus 500, which is $1,600. So much money we have coming in. And then we have expenses. For our expenses, $500 a month. We don't have to change that at all. Groceries was $40 a week. We said that there were 4 weeks in 1 month, so we're going to multiply by 4. That's going to tell us we spend $160 a month on groceries. Tuition and fees is $2,400 twice per year. Twice per year is every 6 months. So for this one, I'm going to divide by 6. And I get 400. And then lastly, incidentals was $120 a week. So we multiply by 4 and we get $480. So for expenses, we have 500 plus 160 plus 400 plus 480. And adding all of those together, 500 plus 160 plus 400 plus 480 gets us a total of 1,540. And so the total cash flow is going to be subtracting the income minus the expenses. So 1,600 minus 1,540, and this problem gives us a total cash flow of $60. That's it for the first lecture. If you have any questions about how they're going or you need more information, certainly send me an email, and I look forward to seeing you all later this week.